All right, and this is the last part about electron configurations and orbital diagrams. This is part 3. This is orbital diagrams, and orbital diagrams are almost identical to electron configurations. They're just written differently. So they have the same process of finding them, starting at the beginning of the periodic table, working your way down to the element you want, listing each section and row, so 1s2, 2s2, 2p6, etc. So you're going to do all that again, except we're going to write it out differently. So in an orbital diagram, remember, you do need to know Hund's rule. That's where each orbital fills up by themselves before doubling up, and Aufbau principle saying that the electrons occupy the lowest energy level possible. So, like I said, orbital diagrams are just like electron configurations, except that there's no shortcut. And I can almost hear you all groaning already. Yes, you do have to start at hydrogen and work your whole way down to the element, and no, there is no shortcut. Okay, so yeah, it will be a good bit of writing, and you'll just have to deal with it. All right, so how to do orbitals. A couple of rules. You need to draw a specific number of lines according to whatever section or orbital you're in. So if you have an S, you draw 1 line. If you have a P, you draw 3. If you have a D, you have F, and if you have a D, you have 5, and an F, you have 7. You have to draw all the lines depending on what letter, what orbital you're looking for, and you're going to use arrows to represent the exponents or the electrons. You're going to fill in the lines for each section with the exponent number. So what does that look like? All right, so let's go back to the first electron configuration that we learned, and that was nitrogen is 1s2, 2s2, 2p3. So if we go back up here to our rules, every time we see an S, we're going to draw 1 line. Every time we see a P, we're going to draw 3, D, we're going to draw 5, and F, we're going to draw 7. So in this case, we see 1 S, so we're going to draw a single line here, and we see another S, so another single line, and then we have a P, so a set of 3. Now, you can't just draw these lines. You are going to have to label them. The neater you make this, the easier it'll be to read later. So when you draw them out, I would suggest putting spaces in, maybe lines to help you visualize them, or labeling them underneath. So 1S gets 1 line, and it's 1S2. So we have an up arrow and a down arrow. Moving on to the next term, we have 2S2. So S is 1 line, and there's an exponent of 2, so up and down. Those exponents are the number of electrons. We have 2 arrows. We can't have them facing the same direction because they have opposite spins, and if you have electrons facing the same way, they'd be like magnets and they would repel each other. And then we come over here to the 2p. Remember, P gets 3 lines, so we draw our 3 lines, and then we fill it in with our 3 exponents. So 1, 2, 3. So remember, Hund's rule says you fill up each seat before doubling up. So that's why we put 1 in each line. And we're facing them all the same direction because they are all the initial electrons, or they all were the -1/2 in the orbital diagram, or the quantum numbers. So if you had 2p4 was your last term there, we would go back and put a down arrow in the first seat of the P section. We would put another down arrow. If this had been 2p2, we would just have this arrow, and this line would be empty. Okay, a couple of things you might want to go back and hit replay on that. If it was depending on whether it was 2p3 or 2p4 or 2p2. Okay, so here is another one to see. Chromium. Remember chromium? Chromium was one of our exceptions, where we took 1 electron out of the closest S and put it into the D for stability, because we wanted to be half full or completely full. So what does it look like? Well, if you space it all out, you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. So again, you fill each line up with 1 electron before doubling up, and you have to draw all the seats that you're allotted for S, P, D, and F. Keep in mind, if you had 3d4, you would have 5 lines and one of them would be empty. Okay, so follow those rules, practice it, make sure that you remember how many seats, how many sublevels are in each orbital. So you have 1, 3, 5, and 7, and everything should be able to fill in accordingly.